theorem. Okay, with this we will finish the theorems we have in our syllabus. So the theorem is reciprocity theorem, and problems we do. Okay, simple. Actually, the theorem is simple. See that. What is this theorem says? Reciprocity theorems, it states that any linear bilateral single source network, in any linear bilateral single source network, the ratio of input to output, that means the ratio of source to response. Okay, listen, that is a point here, only the point. In any linear bilateral single source network, okay, that is a single source network, here the ratio of input to output. Here input means source, output means, we may also say, the ratio of source to response is constant even their positions are interchanged. Okay, the ratio of input to output is constant even their positions are interchanged. Okay, let's see, for understanding it is explained like this. Initially this is a given circuit, let us say this slide is not visible.
Not visible, ma'am.
Now?
No, ma'am.
Okay. Sir? ఇది ఎందుకు ఫుల్ స్క్రీన్ చేసినప్పుడు ఫుల్ స్క్రీన్ ఒక్క నిమిషం అమ్మ స్టూడెంట్స్, ఇది ఫుల్ స్క్రీన్ చేసినప్పుడు స్టూడెంట్స్ కనిపిస్తలేదు. F5 కొట్టినా in slide show. Is it visible now? Students, are you there? Can you hear me?
Not visible, ma'am.
Not visible.
Third slide.
Not visible.
Only third slide is visible, ma'am.
PowerPoint. ఇప్పుడు
Yes, ma'am.
Yes, ma'am.
okay. Okay, so the theorem statement, it states that in any linear single source network, the network is a single source network, the ratio of input to output, okay, the ratio of input to output is constant even their positions are interchanged. Okay, let's see that it is explained like this. Consider this is a given circuit. Let us say here there is a voltage source, and then there are resistors like this, and simple two meshes in the circuit, and they're interested in finding the current here. That means they want the output here. Okay, current in this path. Okay, so what is the source here? This is the source here, applied voltage. Okay, and the output response is here, the current in the terminals here. Let us say these are the output terminals. Okay, now what is the ratio here? What is the ratio of source to, what is the ratio of source to input to output? V by I1. Now case 2. Okay, according to the theorem, interchange their positions. Okay, get the voltage source here. Okay, get the voltage source here at the output terminals, and look at the output. Find the output in the place where the source is there. Let us say that in that case, let us say that is case 2. In that case, the response is, let us say, I2. Okay, then according to the theorem, okay, according to the theorem, we have to show that V by I1 equal to V by I2. V by I1 equal to V by I2. Wait a minute. So see that you can see here clearly, right? So according to the theorem, V by I1 equal to, this is a initial case, the ratio of source to response, and second case after their positions are interchanged. Okay, get the voltage source here and find the response here. Okay, then V by I1 equal to V by I2. That is the theorem statement. Did you understand? By doing a problem, you will be it will be more clear. Yes. Did you understand? Respond in the chat box. Okay, this theorem says that the ratio of source to response is constant even their positions are interchanged. So this is a given circuit here. This is a source and this is a response. Finding the current here, let us say these are the output terminals. Okay, so finding the ratio is V by I1. Then after their positions are interchanged, that means get the voltage source here where the response is fine. Then look at the response where the at the place where the source is there. So in that case, let us say the response is I2. So then in this case, the ratio is V by I2. So as per the theorem, V by I1 equal to V by I2. That is the thing this theorem says. So we are going to verify this by doing a problem. Is it clear? Okay. Next is, see that this is a network. This is a network given doing a problem. For the given network here, verify the reciprocity theorem. Verify the reciprocity theorem. So this is a supply 10 volts and what are the resistors? 1K, okay, like this 2.2K, 3.3K. So how to verify the reciprocity theorem? We know that in reciprocity theorem, we take case 1, case 2. So initially for the given circuit, in case 1, find the ratio between this voltage source and response output here. Find the current in this path. Okay. Then case 2, move the voltage source here, interchange the positions. Okay. So get the voltage source here and find the current in this path. Let us say, okay, that is how we see. So see that case 1, actual circuit, that is okay. So take in the circuit, I want the current I1, that is here. Okay. So to get the current in this path, how to solve this circuit? How to solve this circuit? Can somebody respond in the chat box? How can we find current I1 here? ఎలా చేయొచ్చమ్మా? Number of ways లో చేయొచ్చు. Respond in the chat box. ఇక్కడ సాల్వ్ చేసింది వదిలేయండి, మీరు కూడా ఆలోచించండి. మెష్ అనాలిసిస్ వన్ థింగ్, ఎనీ అదర్? ఎస్, నోడల్ అనాలిసిస్ ఓన్లీ ఒక్కరికే తెలుసా క్లాసులో 64 మందిలో, ఇంకెవరికి రెస్పాండ్ అవ్వట్లేదు. అయిపోయింది, మనము ల్యాబ్స్ చేస్తున్నాము, క్లాసులో ఇంతవరకు చాలా నేర్చుకున్నాం. ఎస్, యూ కెన్ డూ కరెంట్ డివిజన్ ఆల్సో. Okay, I go for the simple one, that is current division here to find the current I1. So for that, here, let us say that the current coming from the supply is, let us say that supply current or total current. For that, find the total resistance here. Find the total resistance here. Okay. So I find, okay, I take RT. Total resistance of the circuit. So to find the total resistance here, how can we start? We start from other side, that is from here. So 2.2K and 3.3K are in parallel. So the resultant of these two will be in series with 1K. Okay, that is RT. So after that RT, I find the total current IT equal to, that is what I have written here. IT equal to supply voltage 10 by the total resistance of the circuit. Okay, RT already it is okay shown here. So what is that value gives? Because these resistances are in kilo ohms, that's why this current is in milliamperes. Following. Next, if you don't understand or any question or any doubt, you can ask in between, no, not a problem, or you can put it in the chat box. Next, after finding the total current IT here, then we want the current in this 3.3K, right? So current here means, what is that current? That is a current in 3.3K. So apply current division. So this is the total current coming up to here. So that is divided among the 2.2K and 3.3K. So according to current division, I1 is given by total current into IT. This is multiplied, not plus. This is multiplication. This is a small mistake here. IT into opposite resistance, that is 2.2K by sum of the two resistances. Are you following? Okay. After that, what we want actually? What we want? We want the ratio of input to output. 10 by V by, okay, I1. So case 1, find that ratio, how much you are getting. V by V is 10, I1 we have 1.724, that is in milliamperes. So that gives 5.8 kilo ohms. Clear? Okay. Next, what we do? Next, we go for the case 2. Okay, interchange the positions of input and output, right? That means source and response. So 10 volts here, where we have taken the current previously. So keep the voltage source here and find the current where we have the voltage source previously. Okay. And in that case, let us say the response, the current is just a different notation I2. Okay. Okay, for just for identification. In case 2, what is the response? I2. So here again the same. Solve this circuit, analyze this circuit, find the current I2. Okay, so same thing, we can solve this circuit either by mesh analysis or nodal analysis or current division. I'm going for the simple one, current division. To find the current here, that means that is a current I2 is a current in 1K. I find the total current coming from the supply here. Let us say that IT dash. Okay, just a different notation because previously in case 1 we have taken IT. So that's why here I have taken IT dash. So to find this IT dash current, I need the total resistance here. Let us say that RT dash. So after finding, how do you find RT dash? RT dash here at these terminals I want, right? Across these two terminals. So I start from the other side. 1 and 2.2 are in parallel. The resultant of these two will be in series with 3.3. Okay. So IT dash is written as 10 by RT dash. That is substituted for RT dash. Okay. Calculating. So that gives 3.98 kilo ohms. So finally the current is given by, okay, supply voltage by that total resistance 2.5 milliamperes. Now what we want? We want current in I2 here in this 1K. So apply current division. So that is given by I2 equal to IT dash into, this is again small mistake here. This is not plus, this is multiplication into 2.2 by opposite resistance by 2.2 plus 1. Okay. Among these two resistors, we are finding the current division. Okay. So that's why. What that gives 1.723. So finally, what we want? We want the ratio of source to response, right? In case 2. Okay, case 2 also. 10 by, that means V by I2. That is 10 by, what is the I2 value we obtained? 1.723. Okay, now check, is it same previously? In case 1, what is the? Previously, what is the ratio? 5.8, case 1 also. 5.8 K, case 2 also 5.8. So finally, we say that reciprocity theorem is proved. Is it clear? Respond in the chat box. Any question, any doubt? We do another problem. We go for another problem. Okay. Do this problem. Go down. Note చేయండి అందరూ. They only mentioned verify the reciprocity theorem for the voltage V and current I. That means they have given this is V, this is I. Okay. In the network shown in figure. Note చేసుకున్నారా? Tell me. So current here, current is the output is a current here. Okay. In this side. Okay. So initially case one, no problem. So we find the current I. Okay, case one, you for the given circuit as usual, solve the and find the current I. Excuse me. Then ratio V by I. Case one V by I. Find the V by I ratio. Then for case two, this voltage source comes this side, right? And we find the current I simply here, where the source is. Okay. This is a case one and case two. This is a circuit for case two. Move the voltage source from here to here and finding the response current, okay, I this side where the source is. That's it. So in case to solve this circuit to find this current I, then ratio. And see you're getting the same ratio as per the theorem. Are you doing? Let me know in case one, what is the I and what is the ratio. You can solve it by using the same idea, using current division. First find the total current. Any question here? Let us say that IT. Okay, so find IT. Now IT is fine. Done by RT. Where is RT? Across the source. Here, right? That is given by, okay, at these terminals we want RT. So come from this side, 4 ohms, 2 plus 2 in series with 3, 4 in parallel with 3 ohms. That resultant will be in series with 2. Four into 3 by 4 plus 3. ఎంత వస్తుందమ్మా 12/7 అది. IT 2.69 అంటమ్మా, కరెక్టేనా? యూనిట్స్ ఏంటి 2.69? milliamperes. Others check. Are you getting the same answer? Amperes. అమ్మ ఒకసారి చెక్ చేయండి, అది ఆంపియర్స్ మిల్లీ ఆంపియర్స్ చెప్పండి. సో ఆంపియర్స్ అవుతుంది నాకు తెలిసి. సో 2.69 amperes. So now I. Therefore, I equal to IT into ఇక్కడ దాకా వస్తుంది IT. సో దీనిలో కావాలి మనకి, ఈ పార్ట్ లో కావాలి ఆపోజిట్ రెసిస్టెన్స్ 3 by total 3 plus 2 plus 2. Okay. Tell me. $1.15 అయ్యా ఏమ్మా? అయ్యి ఎంత వచ్చింది? Now, ratio. V by I. ఇక్కడ I ఇచ్చారు కాబట్టి మనం అదే యూజ్ చేస్తాం. 10 by 1.15 ఎంత వచ్చింది? 8.69 ఏంటిది 8.69? V by I రేషియో చెప్పండి నాకు. V by I అంటే యూనిట్స్ వచ్చేసి ఓమ్స్ అమ్మ. కాకపోతే మీకు మిల్లీ ఓమ్స్ లోనా ఓమ్స్ లో వచ్చిందా కిలో ఓమ్స్ లో వచ్చిందా చూసుకోవాలి. 10 by 1.15 ఏమొచ్చింది? ఓమ్సా? రైట్. క్లియర్? క్లాస్ అయిపోయేటప్పుడు ఓట్ చేయాలంటున్నారు. నెక్స్ట్ టైం నుంచి అలో చేయండి. ఫస్ట్ కేస్ 1 8.69 వచ్చిందమ్మా. ఓకే కదా? ఇక్కడ ఏమైనా క్వశ్చన్స్ ఉన్నాయా ఎవరికైనా? Now go for the next circuit. Case 2. So interchange the positions of supply and response. That means source comes here and find the current this side. Okay, that's it. Any questions under the circuit? So RT dash here I want, so I come from this side. 2 and 3 I run parallel. That is in series with 4 ohms. 2 plus 2, right? IT dash 1.923 వచ్చిందంటమ్మా, చెక్ చేయండి ఎవరన్నా. యాక్చువల్గా 2 ohms ఇటువైపు చూపించాలి, ఎందుకంటే ఆర్టీ డాష్ ఇప్పుడు అంటున్నాను కాబట్టి 2 ohms కూడా ఇటువైపు ఉండాలి. ఓకే, I think 1.923 is right answer. Then I mute yourself. Okay, IT dash into ఈ ఎలిమెంట్ లో కావాలి కాబట్టి 3 ప్లస్ అమ్మా ఎవరైనా చెప్పండి ఐ ఎంత వస్తుంది 1.15 కరెక్ట్ అయినా 1.15 వచ్చింది అంటాము కేస్ 2 now ratio v by I case 2 v by I ratio 10 by so I think previously also we have the same answer same I yes is it clear we will get the same answer I think how much 8 point 694 so finally say that v by case 1 case 2 v by I equal to v by I so theorem is verified sorry this is Ohm's so any questions as per reciprocity theorem reciprocity theorem okay with this we finish the theorems next class I start the next topic that is second unit the next topic half of the unit is over that is module 2 say half of the module is over next we have a new topic network graph theory we say that network topology that is different topic with this we finish the theorems okay go through the question bank and start solving okay any questions are you solving question bank see you have time right so start parallelly at least twice a day one I mean for every 2 days at least do for 1 hour like that your question bank I said that your internal paper question paper completely from the question bank only not only that it is a practice to your SE exams also end exams also so if you practice now itself it will be easier for the exam time any questions